Good morning to all of you. Myself, Professor NVRP from SND College of Engineering and Research Center, Eula, working as a assistant professor in Electrical Engineering Department. Now, we will see the new topic, that is root of polynomial equation using Birge Vieta method. In previous video or in previous lecture, we already studied that the root of equation. What is root of equation? The number of methods to find the root of equation. That is, first one is Descartes rule of sign and intermediate value theorem. In that, you can find the only number of nature of roots, nature of roots, and also find the intervals in which the roots are present. But in that method, you can find the roots. You can find the real roots by using Birge Vieta method. This is an iterative method to find a real root of n order polynomial equation. In that, you can perform the number of iterations to find the root of real root of an polynomial equation. Consider an equation. Suppose x raised to n plus a1 x raised to n minus 1 plus a2 x raised to n minus 2 plus dash an minus 1 plus an is equal to 0. If alpha is one real root of pn of x, p raised to n of x is equal to 0, then p raised to n of x is equal to 0, then Pn of x is equal to x minus alpha into q of n minus qn minus 1 of x, where qn minus 1 of x is a polynomial of degree n minus 1, and it can be written as qn minus 1 of x is equal to x raised to n minus 1 plus b1 into x raised to n minus 2 plus b raised to n minus 2 bn minus 2 x plus bn minus 1. If p any approximation alpha, then pn of x is equal to x minus p into qn minus 1 of x plus r, where q is quotient, p is a root, and r is a remainder. Then r is the residue which depends on the p. The iterative method, like Newton-Raphson method, is applied to improve the curve of p such that r of p is equal to 0. Let p0 be the initial guess. P0 be the initial guess. Then pi of x, pi plus 1 is equal to pi minus pn of pi upon p raised to 1 plus 1 of pi, where I is equal to 0, 1, up to 10. Now comparing the coefficient of Pn and x minus p, Qn minus 1 of x plus r, then A1 is equal to B1 minus p, and B1 is equal to then A1 plus p. A2 is equal to B2 minus p into B1, and then B2 is equal to A2 minus, A2 plus PB1. AI is equal to BI minus PBI minus 1. BI is equal to AI plus PBI minus 1. This is your finding the values of A and B, where B0 is equal to 1 and R is equal to Bn or is equal to Pn of P. To find Pn of P, let us differentiate the equation Pi is equal to Ai plus Pbi minus 1 with respect to T. dBi by dP is equal to Bi minus 1 plus P into dBi minus 1 upon dP. If we substitute dB by dP is equal to C, then C of I minus 1 is equal to B of I minus 1 plus P into C of I minus 2. Therefore, Ci is equal to Bi plus P into Ci minus 1, where I is 1, comma 2, comma up to n minus 1. Thus, C of I minus 1 is equal to dP of dBn upon dP is equal to P raised to n of P is equal to AR upon dP. By using Newton's method, we can write written as Pi minus I plus 1 is equal to Pi minus Pn upon Cn minus 1. This is the equation to find the next value. To find the next value after solving the iteration. On convergence, this process will give one root P of the polynomial equation, that is P of x is equal to 0. Now deflected polynomial equation Qn minus 1 of x is equal to 0 can be obtained by synthetic division process. Horner's synthetic division method process, and this method is called as Birge Vieta method. Every iteration makes use of Newton-Raphson method combined with Horner's synthetic division to find the real roots of polynomial equations. And steps to solve problems for Birge Vieta method is obtain Bn of x using synthetic division, obtain next case using the formula Pi plus 1 is equal to Pi minus Bn upon Cn minus 1. Repeat the above steps until root is obtained to required number of places. So stop here, and in next lecture we will see the problems on that method, that is Birge Vieta method.